It turns out that data sets like the one in example 2 can be modeled with what's called a quadratic function. You might have encountered quadratic functions in a previous algebra class. Quadratic functions can be written in a form a number times x squared plus a number times x plus a constant. And the only requirement then is that that first number a can't be 0, right? So what that means is that this first term here can't be 0. So a basic example of a quadratic function might be f of x is 3x squared plus 2x plus 3. So here's my a, b, and c. This is a quadratic function because it fits the form ax squared plus bx plus c, where a is 3, b is 2, and c is 3 again. Slightly harder to spot is f of x is 2x squared minus 4. We have to notice that this could be written as 2x squared plus 0x minus 4. We can always add in any term we like if we multiply it by 0, because anything times 0 is 0, and adding 0 doesn't change anything. So this is also a quadratic function, because it also fits the form. Here we have a equals 2, b equals 0, c equals negative 4. And remember, a is not allowed to be 0, but b and or c, those can be 0. But this last example is not a quadratic function. And the reason for that is it has this x to the 1.2, which is not allowed. We have to have an x squared. We're allowed to have an x. We're allowed to have a constant. We're not allowed to have anything else in a quadratic function. So this is not a quadratic function because x to the power 1.2 is not allowed in quadratic functions. Of course, we can evaluate quadratic functions just like we can any other function. So if f of x is the opposite of x squared plus 2x minus 1, we can take f of negative 3 just by plugging in negative 3 for x. So we have the opposite of negative 3 squared plus 2 times negative 3 minus 1. Now, remember negative 3 squared, that means negative 3 times another negative 3. 3 times 3 is 9, and a negative times a negative is positive. So that works out to positive 9. So we have the opposite of a positive 9. And then 2 times negative 3 is negative 6. And then we have a minus 1. Negative 9 minus 6 is negative 15. Negative 15 minus 1 is negative 16. Now, in reality, we would almost certainly throw that into the calculator. And I'm going to show you 2 ways to do that. One way we can do this is by saying the opposite of negative 3 squared plus 2 times negative 3 minus 1, which gives us our negative 16. But we have to be careful, because if we don't put that negative 3 in parentheses, we get a different answer. What's happening Remember we said -3 squared means -3 times -3. Without the parentheses, the calculator is going to say, take the number 3, square it, and then make the result negative. Whenever we enter a negative number on a calculator and we're planning to take a power of it, we need to put parentheses around that number in the calculator to make sure that the calculator applies the negative sign before it applies the exponent. There is another way we could go about this, and especially if you find that you lose track of parentheses, you might like this option better. -3 is being plugged in for x. So on the calculator, I can say -3, and then I have this button labeled STO for store, right above the on button, store, and I can store that as my x variable. Now, ordinarily, we don't want to punch in x on the main screen of the calculator, because what the calculator does if we punch in x is it plugs in a number for that x. But we just told the calculator what number to plug in. So now if we punch in -x squared plus 2x minus 1, it plugs in -3 because that's what we told it to do. One advantage of doing it this way is in the next part of this question, we want to take f of 2, which is going to be the opposite of 2 squared plus 2 times 2 minus 1, which of course we could just punch into the calculator manually. But also, if we take the number 2 and store it in x, we can scroll up and grab that expression with an x in it and do it again. And now, because we have 2 stored in x, the calculator will plug in 2 for x. This can be useful, especially if we have a function that's really messy to punch in on the calculator. So either way, for the second part, we get -1 for f of 2. F of -3 gave us -16. And we'll remember when we're plugging into a function with exponents in it, in this case a quadratic function, we have to remember to put negative numbers in parentheses, unless we use calculator trickery by storing that negative number to x.